Today we will see a low-cost method of sending wireless data between two Arduino without using Wi-Fi or Bluetooth. This is RF433 MHz module. These modules are extremely easy to use. Each module has only 3 connections, and 2 of those connections are for power. The receiver has 4 pins, but 2 are internally joined together. So the remaining connection is for data in on the transmitter and data out on the receiver. The modules are also very tiny, allowing you to incorporate a wireless interface into any project. So let's make a wireless weather station using these RF433 MHz modules. We need 2 Arduinos, one for transmitter, another for receiver. Then we need RF433 MHz modules. We need 2 small breadboard for circuit connection. I have 2 DHT sensor, DHT22 and DHT11. I will use DHT22. You can use any of one. Then we need a display. This is 1602 LCD display with I2C protocol. To power up the Arduino remotely, I will use 9V battery with DC power jack. Here one for transmitter, another one for receiver. These 2 cables to upload the code to the Arduino. Lastly, we need some jumper wires to connect the circuit. Here I have 2 types of jumper wires. One is male to male, another is male to female. This is Arduino Uno. Arduino Uno is a flexible and easy to use programmable open source microcontroller board that can be integrated into a variety of electronic projects. In this video, we will not go details about Arduino. We will just use this Arduino for our project. So let's start with the connection of transmitter circuit. So we need DST module, we need transmitter module, we need a small breadboard and some jumper wires. Let's fix this DHT22 temperature and humidity sensor on this small breadboard. In the back side of the sensor is written the pin names. So according to my connection, the orange color wire is negative, the green color wire is positive, and the yellow color wire is the signal. Orange color wire, which is negative, will go to Arduino ground pin, and the green color wire, which is positive, will go to Arduino 5V. Yellow color wire, which is output signal from DHT22 sensor, will connect to the Arduino digital pin 9. Now I will connect the transmitter module. From the transmitter module, we will get 3 wires. Green wire is VCC, the yellow wire is output, and the orange wire is ground. Connecting this green color wire with 5V, which comes from Arduino for DHT sensor, and the orange color with the ground. Yellow color output will connect to Arduino digital pin 12. Here the transmitter circuit is now ready. Now we have to upload the code. I will share the code in the description. You can download from the link. You have to include some library. If you don't have this included library in your Arduino IDE, you can't upload this code. So include both the Radiohead library and the Arduino SPI library. I will share zip file of Radiohead library in the description. You just download and follow the process. After downloading Radiohead library, just go to Sketch and include library, add zip library. Here you will go to the directory of that downloaded Radiohead library and just upload this. I already have this library in my Arduino IDE, you can see. You have to include another library for DHT sensor. Just like before, go to the sketch, then include library and manage library. This library you can find from the Arduino IDE. When library manager appears, you can find the search box. Just type in the search box dht.h. You can see dht.h, same like library name. So after searching, you will get many libraries with the same name. So here this library you need to install, DHT sensor library by Adafruit. I already installed this library. So after including all the libraries, now I will upload the code. For uploading the code, I have to select the port. Here I select my port, uploading. So done uploading. We can check the serial monitor to make sure that the DHT sensor is working fine. Here I can see I'm getting the humidity and temperature reading correctly. Now let's make the receiver circuit. For receiver circuit, we'll use a small breadboard, a LCD monitor and some jumper wires. And of course the receiver module. Let's hook up the receiver module with a small breadboard. Then I will connect 3 wires with this receiver module. According to my connection, here the white color wire is the ground, blue color wire is the VCC and the purple color wire is the signal. In the receiver module, the middle 2 pins are internally connected and these represent the signal. So we can take the signal from any pins from these 2. After that, I will connect this white color wire to the ground from Arduino and the blue color wire to the 5 volt of Arduino and the purple color, which is signal, I will connect this with the digital pin of 11 from Arduino. Now we will hook up the LCD display. As this display is attached with I2C protocol, so we will get only 4 pins from this display. Here you can see the first pin is ground, the second pin is VCC, the third pin is data and the last one is serial clock. According to my connection, this brown color wire is the ground and the red color wire is the VCC. So I am connecting the brown color wire with the ground and red color wire with 5 volt, which came from Arduino for receiver module. And the other 2 wires from the display, which are serial data and serial clock, will be connected with Arduino analog pins 4 and 5. Here the orange color is serial data, which is connected with analog 4, and the yellow color, which is serial clock, will connect with analog 5. After completing the circuit connection, now we will upload the code. Here is the code. I will share this code in the description. You can download it and you can upload. But before upload, you have to include the library for liquid crystal I2C. So just like before how you did for DHT sensor, you have to include this library. You can find this library in the description. Like I did before, now I will select my port, then I'll upload the code. So here done uploading. So still we didn't get any result because we have to power up the transmitter circuit. Here I am using my another USB port from my laptop and powering up this transmitter. Now we'll get data. So here you can see the temperature and humidity reading. Sending data wirelessly has been established by these RF433 MHz modules. Now I will power up both transmitter and receiver Arduinos with these 9-volt batteries. So after connecting the 9-volt batteries, you can see this is the final result. There is no physical connection between two circuits. I am trying to increase the temperature by the soldering iron to check the real-time data. Yes, it's working. You can see the temperature is rising in the display. You can use this technique for transmitting multiple chunks of data for other applications also. Thanks for watching this video. Have a good day.